This tutorial shows how to manage the sections determining the volume of the board, and the way in which the shapes are distributed along the board. We will use the default shortboard project, of which we will load a copy. To modify the shape. So here it is, the copy is loaded. We show the sections in the Board Aspect tab. We select the shaped phase. We hide the fins. We are going to hide the shape room. By selecting here, a display by points, and displaying the sections, we see the sections. We are going to remove the custom tail to have a simple shape. We go to the Shape tab at the section level. So the sections are the slices that we see here. To select the sections, we have a cursor. When the cursor is moved, the selected section varies, and the diagram which is at the bottom is updated according to the selected section. We can also see in the diagram on the left the position of the section. The width of the section and its position are displayed. We can operate the bevel cursor to select the chamfer of the selected section, and each chamfer corresponds to a point in the diagram. We can thus select the place we want on the board. We can display information on the 3D screen relating to the selected point. For example, the distance from the center, the angle from the bottom, the thickness of the section at the selected place, the volume, the width. The board is divided into 10 slices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In physics, it is convenient to standardize spaces, so as not to worry about dimensions. Here we say the board is 1 in length, so each portion is going to measure 0.1. And if we want to know the value of a particular dimension, we just have to multiply by the length of the board. This standardization makes it possible to overcome dimensions, and to think in terms of shapes only. So we cut the board into 10 parts. In the Sections tab at the bottom, 2 chamfer settings, 1 for the tail, and 1 for the nose, which allow you to adjust the bevel of the tail, and the bevel of the nose. We have 2 sections here, which represent in longitudinal section, the tail and the nose. Here I activated a large tail bevel. So we have a sectional view of the tail. We can modify the shape of the tail with this section there. So it's a longitudinal section. This allows us to carve our tail freely. Same thing for the nose, we apply a wide bevel. This section of the nose is longitudinal. So we have 11 sections. A tail section which determines the shape of the tail. 9 intermediate sections which therefore cut into 10 slices. And the nose section here. We will now see how to modify these sections. A section is a board cut, which must remain consistent with its neighbors. If we have a section which is completely different from its neighbors, we will get a misshapen sausage. It is quite difficult to draw sections which have a perfect coherence. It would be necessary for that each section is in adequacy with the preceding section and the next section. Shape-wave dynamics therefore offers a function that will automatically solve this problem by performing a smoothing of the sections. This smoothing function therefore eliminates the defects. A section can simply be taken from the library. We see here some sections of the library. They are actually half sections. I select a section on my 3D. I take a section from the library and I drag it into the board. And we see that the selected section has changed to match the one we just imported. We see that this import between this one and that one will create a discontinuity. This is going to make a weird slice in our board. If here in the aspect edge we show the volume, we see that this section protrudes. The skin of the volume that is drawn is a smoothing. So here we have an average, and we can clearly see the sections that come out of the average, because they diverge too much from their neighbors. So, when we import a section, we can adapt it with its neighbors with a clean shape function. It's a function that will smooth all the sections to make them harmonious with each other. I launch the clean shape function. The sections are thus more harmonious. This gives us a nice regular shape. But the problem is that the section we imported has been overwritten by its neighbors. So we understand that if we want to apply a shape to a place, a section will not be enough. Several sections will have to be applied to define a harmonious board area. So I resume this section here, which I had chosen. OK, flat deck. So we see that here we have a section that is a bit more boxy, with a straight deck, while the sections around it have a rounded deck. If I really want a straight deck on this area, I will select this section, I copy the section, we can do Ctrl and C. And I will select the naming section and paste, we can do Ctrl and V. The section that was behind thus becomes the same, we can paste the copied section as well over the whole area. And when I use the clean shape function, I'll have this area there which will keep the imported straight deck. We have another interesting function for the shaper. So we copied the section, but instead of pasting it completely, we are going to merge it with the present section. i.e., we are going to do an average of the two sections. The one I copied into memory, and the one that is selected. And so I'm not going to completely override and transform the selected section, I'm going to merge it. I merge. and this section there becomes an average. We can thus distribute a section. There I have a flat deck, there I have a rounded deck. We are not going to go from the flat deck to the rounded deck directly. So I copy this one and just merge with the next one. We will thus create a progressive variation. This allows us to carve our board in a harmonious way. If I go back in volume, I see that there are still things that are not pretty. So each time I work on the sections, at the end of my work, I smooth my board with a clean shape function, so that the whole board is harmonious. The whole of our board will thus keep a nice cohesion. So, we saw that we could import sections from our library. We notice that when we import a section of the library, we are offered a choice. Do I preserve the current thickness of the board or not? If I do not preserve the current thickness of the board, the imported section will give its thickness to the board. We're going to experiment here. We're going to preserve the thickness of the board. So the imported section will be adapted in thickness to preserve the thickness of the board. Here the imported section has not changed the thickness in the center of the board. Now if I do the same import again, in the same place, but where I say no, I don't want to preserve the section, the imported section will impose its thickness. We see here that the thickness in the center of the board has increased, so we have the choice, when we import a section. Either we keep the thickness of the board, or the section modifies the thickness of the board. It's a small detail of the import. And now we'll see how to work on a given section in a very precise way. So in the bottom tab, Sections, we have a Shape Section button, which opens the section editor. We see here in the section editor that when we select a section on the drawing, the section editor is updated. We can modify our sections, modify the thickness, etc. And we will find a drawing interface. We find the same type of tool as in the outline editor. If you have already followed the outline tutorial, we can select a range of points and obtain a ruler. With several degrees of flexibility, we will stay in the low enough degrees to have the harmonious tense. We apply and we exit the tool. The section has been modified. We can apply it to the project. And there, we see our section which has been modified on the project. In the section editor, we can change the thickness at the center. And so that's the whole central area of the section. Or change the thickness at the rail. We have a rail balance adjustment, which allows the rail to be deformed. It is useful for directing the water at the exit of the rail and managing the Coanda effect. We can make appear the whole section here to get an overview. I'm going to expand a bit. We notice the rocker line. I don't know if you have already seen the rockers tutorial. The green line below indicates the angle of the bottom generated by the rocker. If the center rocker point is higher than the rail rocker point, a concave is generated. If the center rocker point is lower than the rail rocker point, you have a V. Here we see the effect of the rail rocker and the center rocker tilting the whole section. If I remove the rocker effect here, we see our section like this. We reactivate the rockers. In the section editor, the rail can be isolated. Then we have a section editor, which will be focused on the rail, and it will be a rail editor. And there, I work only on the rail. We keep the possibility here to modify the way in which the rail is left. We can save the rails or the sections. We have thus modified our section, apply to the project. And so, when we have just applied a section, we perform a clean shape. If I like the series of sections, I can save it. And thus be able to apply this series of sections on another board. When you modify a section, you don't modify the outline, it's an important detail. We do have independent and separate modules. And here, for example, we are going to open another board. A fish, like that. On this board there, we see narrow sections. It's a board that has little volume. We are going to use the series of sections that we have created, which is in the library, at the level of the series of sections. Series sections test, we drag into the project. So we import the series of sections. OK. And here, we modified our board by integrating our series of sections. But we did not modify the outline of the fish. So we can see that we have very modular parts that allow us to create boards by modules without having to redo everything each time. This is the end of this tutorial on working sections with Shapeways Dynamics software.